Hello, and welcome to the North Green Security course on learning Linux for penetration testers. I'm Dan Cannon, and I'll be taking you through this course. If you're wondering who I am, my name is Dan, and I've spent the vast majority of my career as a penetration tester, and am the founder of the company North Green Security. We are a security consultancy and training organization, so not only do we conduct penetration tests against our clients' systems, but we also train other testers so that they could be more effective in their work and progress through their career. In this course, we're going to look at Kali Linux and how to use it as a penetration tester. So if you're new to Linux, this is the course for you. We're here to help. During the course, we're going to focus on how to set up a virtual machine that you can use. We'll then take a bit of a tour of the operating system so you can become familiar with it, how it differs to operating systems you may have dealt with in the past, whether they are Windows or Mac. And then we're going to learn how to actually use Kali. This is going to cover what the terminal is and how we use it, how to interact with folders and files. We're going to have a little bit of a look about how we can understand the concept of privileges and permissions in Linux. They're both very important concepts. And how a Linux machine connects to the network. How does it get an IP address? How can you control that? As a penetration tester, it's very important to be able to make sure that you understand how your computer is connecting to a network environment. Then we're going to look at updating and installing some tools and some key commands to get you using Bash like a pro and being able to just get the information you need at speed and be able to do all the different kinds of tasks that you may come up against as you start using Linux more and more. So now that we know what we're going to learn, let's go and get ourselves a Kali VM. Virtual machines are commonly referred to as VMs, and they allow us to run different operating systems on our computer as though we had another machine. Now, the simplest way to do this is to go and download some software called VMware or VirtualBox, if you'd rather. For this course, we are going to use VMware. Commonly, I use it more because the support of hardware pass-through is typically better. Hardware pass-through means being able to give a virtual machine access to the actual physical hardware that might be plugged into my computer. So you can see if you look at the bottom of this screen that I have a Windows machine, but I'm still able to use the VMware software to run this computer as though it's a Kali Linux machine. So go to Google and simply type get VMware. And we're going to just click this link here of VMware Workstation Pro available. This is free software now. It wasn't always free, but it is now. And we're going to scroll down. And if you're on a Mac, you can get the VMware Fusion player. Or if you're on Windows or Linux, the VMware Workstation. Now, when this page loads, it's going to give us a requirement to create a Broadcom account. It's a free account, and once you've created it, you will get a download to be able to run an executable that will install VMware, and this will allow you to be able to run virtual machines. Once you've got that downloaded and installed, it will look something like this. So this is VMware Workstation. This allows us to have multiple virtual machines running at the same time if we want, and it means that we can connect to different virtual machines that we might have. But we need to go and get those virtual machines and install them into the tool. So how do we do that? We simply go out to Google, type get Kali, and follow that first link. Now, this is going to give us an option to download a virtual machine over here. And depending on what software you choose to use, you can go download any format of Kali. Now, it's down to your personal choice what software you use to host virtual machines on your computer. But for us in this video, we are going to download the VMware supported virtual machine of Kali. And you can see this is just going to download about a 3 gig file, and it will take, depending on your internet, anywhere between 10 and 30 minutes. When this downloads, that 3.1 gig is quite small. When this downloads, it will be in a 7-zip compressed file format. So while it's downloading, if you don't have it already installed, I want you to just go back to Google and type 7-zip, and you will get to this website. So if we just go back, you'll see that just putting 7-zip into Google, our first link will give us the ability to download the executable of 7-zip, and this will allow us to extract the Kali virtual machine from our download. So I recommend you pause the video at this point until you have this downloaded, and then come back and we will get Kali set up in VMware. So welcome back from getting your Kali VM downloaded. You should see somewhere on your computer, probably in your downloads folder, a file that looks like this. I've just moved this to my documents and virtual machines folder so that it's not sat in my downloads. We're going to simply right click and we will have the option to extract this here with 7-zip. Now this will take approximately a minute or two, depending on the speed of your computer, while it extracts. Now that we have that extracted, we can see we have a folder here that has all of the files that are needed. So this is where the actual virtual machine is stored. And what we can do is we can simply go to VMware Workstation and open that file. So we double click this, it will load up our new Kali testing machine. And this is how it looks. So by default, it's got 2 gig of RAM, it's got an 80 gig hard drive. Depending on the specs of your computer, you can change this if you want. You'll need to change it while it's powered off. To change it, you can simply go to this Edit Virtual Machines settings. So I'm going to just give this 4 gig of RAM instead of 2, just to make sure it's got a bit more power behind it. Okay, and we can simply just click up here to this 4 gig and say, yeah, I would like this to have 4 gig of RAM. Now, obviously, this depends on the power of your computer. And then we can get started. We can power on our virtual machine, and we can see when you've got multiple virtual machines, you've got these nice little tabs here so that you can jump from one to another. And it's going to allow us to be able to just work within a Linux computer, even though my laptop is running a Windows operating system. So now that we've got Kali installed as a VM on our machine, we can load it up and see what it looks like, how it works. If you've used the VM template from the Get Kali link earlier, you will have a generically built Kali machine with a username and password of Kali and Kali. This will log you into the machine and give you the ability to go on this tool. So now we're logged into the machine. We can see that this is how it looks. You may get a slightly different look to your Kali machine depending when you download it, what version of Kali you're using, anything like that. So it may not look exactly identical to this, but you will get something relatively similar to this. Now it looks different from Windows if that's what you're familiar with, but it doesn't take too long before you get used to it. In the top left up here, we've got our equivalent of the Start menu, where we can go through and we can load different applications. You can see these are grouped together so that depending what activity you're doing, there are tools installed ready for you to be able to use them, and we can search for different tools if we want. So off the top of my head, Hydra we can search for that and find that tool is installed. Okay. We also have our file explorer over here. This is essentially the ability to go to my computer. So if we open up that folder, we can see that this is the file structure, the folder structure of Kali Linux. Now, instead of having something like the C drive, we just have the file system. This is where all the important files are. There is a lot that we could go into to explain the ins and outs of how the Linux file system works, but in the interest of not overloading you with too much information, we're going to stick to some key areas. We're going to look at the home drive. So this is essentially your My Documents area within the Kali Linux operating system. So we've logged in to the Kali user, and we can go and see this is our desktop. It's currently got nothing in it, but we can go have a look at our documents. This is where downloads are going to be. We click over here, and this is our Windows equivalent of C users, whatever your username is. So it's referred to as the home directory. If we click up here to this little bar, we get the folder location that we're looking at. So it is /home/Kali, and that name changes depending what username you're using. Okay, we can go back up to the root directory, and we can see we've got another important area, the etc folder. So etc is all about configuration files within Linux. There are a lot of them here. We're going to go over some of this later on when we have a look at some settings, when we have a look at some important files within Kali Linux. But this is essentially where lots of configuration files are going to be. So this is how you can get familiar with being able to graphically look at the folder structure of a Linux environment. We are going to be spending most of our time in the terminal, which is what we call the command line. So just be prepared for that. We'll get familiar with how to navigate that folder structure without using the GUI, the graphical user interface. And then we've got a couple of pinned pieces of software here. We've got a text editor, we've got a browser, and we've got the terminal. This is, when we click this, this is where we will be doing a lot of our work. This loads up a bash shell. This is how we are going to interact with the Linux operating system. It's how we're going to give commands to the machine. Last and not least, for anyone who's not seen it before, we've got this option over here with this bit part of our menu system. These are different desktops, essentially. So we've got a terminal running in desktop 1, but we can load up a second one and use it for different activities. It's just something that can be helpful if you've got a couple of different activities on the go and you just want to have that kind of separation of software, or it just is easier for you to work through that. Okay, so let's jump into being able to understand the terminal. Okay, so this is where we will spend most of our time when it comes to using Kali. Most tools are launched straight from the terminal. A lot of penetration testing and ethical hacking tools do not have particularly pretty graphical interfaces. Instead, they are command line based. So they are terminal tools that we use from the bash shell that we've got. Equally, we need to be able to read files, add files, create files, generally understand where we are within the operating system from the terminal. So let's go through some introductory kind of commands of how we can understand the terminal. So first of all, we can run what's called a pwd command. This is the present working directory. And this shows us that we're in that /home/Kali directory. This is our user's home directory. Okay, we've logged into Kali, and this user has a space on the computer to store their files. We can look at what files they have by using the ls command. That means list. And we can see that at the minute we don't have any files in here, we just have folders. So if I just bring up the graphical interface and put it next to it, you'll be able to see what we're looking at. This is showing the exact same information. Okay, we can see we have folders over here, but no files. And we can see over here we have listed all the contents of the home directory, and it is showing us the folders available to us. Okay, when we're looking at this terminal, we get a bit more information than just being able to see what folders and files might exist. We can see who we're currently logged in as. We are currently logged in as the Kali user. This can be helpful later on when it comes to moving from one user to another, escalating up to the root user. But this shows us what user account we are currently running as. And this Kali here shows us the host name of our machine. So this computer is called Kali. And so we are logged in as Kali onto the machine called Kali. Okay, and we can see that by typing in the word hostname. We can see that that is our, the name of this machine. It can take a little bit of time to get used to interacting with a machine this way, and there are always going to be times where you forget how you've done something. One thing to be aware of is that by pressing the up arrow key, you can go back through the different commands you've used. So this is a completely fresh build at the minute, and you can see by going up, I can see the last 3 commands that I've done. They're the only 3 commands that I've used, and by going down, I can go back down them. I can also type the word history, and it will show me the commands that I've ran. This can be really helpful when you're just getting familiar and you know that you've done something previously, but you can't quite remember how you did it. You can either use the up and down arrows or look at the history. Now you may want to change the password of your Kali user. It's good practice to make sure you're using a good password. So how do we do that? From the terminal, we can simply type passwd, and we will get a prompt to change our password. So I'm going to put my current password of Kali, which is the default. You can't see any text being input, but I promise you it is there. Okay. In the terminal, when we're typing in information like passwords, we don't see special characters like asterisks populating the screen to give us that reassurance that we've entered data. Instead, it is just blank. So don't think that it's not taking your input in. Okay, if I hit enter, it's read that I've put the correct password in, and it's asking for my new password. Now I'm just going to type password here, and you can see that both times I put that in, it doesn't show any indication on the screen that I'm editing that I'm inputting the data, but the command has ran successfully, and that means that I've been able to change my password on this machine. Okay, so obviously other key commands that we might want to be able to do, we might want to be able to change what directory we are in within the terminal. And we can do this by simply typing the cd command, change directory. Okay, so if I think that I want to go to my downloads folder, I can just cd to downloads. I'm going to stop at the word down and just demonstrate that if I hit the tab key, it will auto complete. This is going to save you a lot of time and save you a lot of effort when it comes to spelling mistakes that you are bound to make, because we all do. Once I change to this directory, to this folder, we can see that I get this new addition to my prompt. Okay, so this is my downloads folder, and this tilde just means that I'm in the home directory, so home downloads. Okay, so I am in /home/Kali/downloads. Okay, I can cd back up to the main home directory by either cding to home Kali, or I can just use a double dot. Okay, and you'll see that that downloads folder location indicator has gone. And again, if I do this list, I'm back to this location on the machine. So this is how we can move up and down the computer. If we want to go to the very top of the machine, the very root of the computer, I can cd to slash. And you can see that now when I list the files, I get this same screen here, but displayed over here. And we can see what was mentioned before. We've got the areas like home over here. We've got etc for our configuration files. We've got a temp folder over here. That's going to be useful in future when it comes to being able to just upload files to a machine or write files to a location that we're not too fussed about, but we just want to have a safe space to be able to write files. Other key areas, the opt is for optional software, so it can be a useful place to be able to install additional tools so that you can keep them all stored in one centralized folder that you can go query later. And we've got the root directory as well. This is for the root user. Now on Kali, we are the user account Kali. Root can be thought of like system or administrator on a Windows machine. It is the most important account on a Linux machine. Be aware that anything you run as root will just run. We're going to talk about privileges a little bit later, but Linux is not going to give you safety rails if you run commands as root. If you decide you want to delete absolutely key files for your machine as root, it will delete those for you. If you decide you want to modify them, it will. So we need to be aware of that. So what we can do is cd back to our /home/Kali. Again, I've just tabbed to auto-complete that. Check we're in the right place. And let's start having a look at folders and files next. Okay, so let's talk about folders and files. Now, because you'll be spending a lot of time in the terminal, it's useful to be able to create folders and files from this interface instead of relying on a GUI. So let's have a bit of a look at the commands that we need and that we can use. So we can first of all just check where we are in the file system by running the pwd command. And we can see that we're in the home Kali directory. So this is our home directory of our user. Now, if we want to list the files and folders, we can run the ls command, and we can see we get our color-coded folders here, all in blue, showing that these are folders. Now, if we want to create a file, we've got a couple of different options. We can simply type nano, and let's create file 1. And this will take us into a command line text editor, if you will. So we can then just type, this is file 1. And we can do Control X that we see at the bottom saying, do you want to exit? And the save buffer just essentially means, do we want to save the changes we've made? So we're going to hit yes, and yes, I want to save it to the file 1. Now, if I run that ls command again, we can now see that I've got file 1 in white, showing that this is a file, not a folder. We can also use the echo command to create files. So we can type echo, this is file 2. And we can use an angle bracket to go to file 2. And when we run our list command, we can see that we've got file 2. Now, to read the contents of these files, we can use the cat command. So cat file 1, this is file 1, cat file 2, this is file 2. So it's a simple process of being able to create files. Now, what if we wanted to copy one of these files? Well, we can simply run the command cp for copy, and we'll take file 2, and we will copy it to a file called file 3. So this is the format of how to copy. You give it the file that you want to copy, and then you give it the file that you want it to be called. And again, a simple ls, we can see there is a file 3 now. Now, it's really important when it comes to editing files to understand the difference between using tools like nano and echo. If I want to change the contents of file 3, I can type nano file 3, and I can delete this and say, no, this is file 3, and save that. Let's just show that that's updated. But I can also add data to this with the echo command. So if I type echo, this is a new line in file 3, I can use this double arrow to say I'd like to append this to the end of the file. And now if I count that file, you can see there is an additional line of data. Now the reason I said it's important to understand how echo works is because that double arrow means to add data to the end of the file. If I was to type echo, this is the one and only line, and use a single arrow for file 3, this is going to overwrite all the data. This is essentially saying I would like to take this input and save it as a file called file 3, and I will overwrite anything that is there. So we can see we only have one line of data. This is why command line can be a little bit intimidating to some people, because we don't necessarily always get a prompt to turn around and say, are you sure you want to do this? Are you sure you want to make these changes? Linux trusts users to know what they're doing, which is great in some ways, but it can mean that you have the ability to really screw stuff up, and you've got the ability to overwrite data that is helpful. One thing you may notice is that when we run this ls command, that file 1, 2, and 3 have no file extensions. They are all clearly text files, that's what I've put in them, but there is no file extension. That is because, again, when you are creating files from the command line, Linux trusts you to know what you're doing. So if you need to have a file extension so that you can open a file in different pieces of software, then you need to do that when you are creating the file. So I can type, for instance, nano file4.txt. This is file 4. And you'll see it treats files with extensions and without extensions the exact same way. It's just the process of being able to decide how you want the files to be. So let's look at folders. Let's say we don't want these files just spread in our home directory. We'd like to put them into a folder. I can run the command mkdir, that's make directory. A directory is a folder. So make directory of folder 1. Okay, I'm going to just list out the contents of my home drive, and we can see folder 1 in blue. It's a folder. I now have a folder that I've created from the command line. And I can move all of these files into that folder. Now, I don't have to copy and paste them into it. It's a move command, which is mv. Okay, now I can either turn around and say I'd like to, move file, let's say file 1 for the minute, into folder, and it will disappear. It will move into the folder 1 folder. But if I've got multiple files that are all similarly named, like I do here, I can also do a mass move. So I can turn around and say, you know what, I would like to move anything that starts with the word file. So I'm going to give it file as an asterisk. It's a wildcard character, meaning anything after the word file will count for this search. So file 2, file 3, and file 4.txt will all match this criteria. I'd like to move them into folder 1. And if we list, we'll see they're all gone. And I can list that folder without moving into it if I want to. I can just list folder 1 and see that they are all there. So all my files have been moved into it. Now I can change directory with the cd command to go into here. Start listing out files again, and I can change directory to come back out. Now, when you're changing directory, if you only want to go up one folder, you can just use this double dot, and you will go back one folder. We can see if we do that again, if we change directory to folder 1, our prompt has changed. It's telling us where we are. If we run a pwd, we can see we're /home/Kali/folder1. This tilde here is saying that we're in the home directory of our current user. So it doesn't have to say /home/Kali. It just uses this tilde and then /folder1. But if I would like to go back to /home/Kali, I don't have to type that out. I can just type out ... and you will see that present working directory, I've gone up one folder again. So that's really helpful when it comes to being able to navigate through the folder structure that you might create, and be able to just nice and easily copy and move files around. But what if we want to copy the entirety of that folder? We can go through essentially the same process, and we can run the cp command, and we can copy folder 1 to folder 2. Now you'll see that this time we get this error saying, -r not specified. This is omitting the directory folder 1. It's not going to copy this folder. That's because there is contents within there, so we need to do what's called a recursive copy. If I just hit the up arrow, go back and add this R, what's going to happen now is it's going to try and copy folder 1 and all of its contents into folder 2. So I can say I now have a folder 2, and if I ls folder 1 and ls folder 2, you can see they've got the exact same contents. It's successfully copied that file. Sorry, it's successfully copied that folder and all of its contents. One thing we can think about, in the same way that we can ls each of these different folders, we can list the contents of all the folders in our directory. This can sometimes be helpful when you just want a high-level kind of bird's eye view of everything you have. And we can see that I have, within my home directory, I've got a desktop folder. I've already put some files in a documents folder, and I've got the folder 1 and folder 2 areas that we've just created. And this can be really helpful when it comes to just getting that kind of bird's eye view and being able to move things around. I don't necessarily need to go into the different folders to move things either. I can, like before, I can just move from the documents folder file 2.txt into folder 1 if I would like. And then if we do that ls*, we can see that's no longer in documents, it's now in folder 1. So it's really helpful at being able to use the terminal in an effective way without having to constantly go up and down the folder structure. We have good amounts of control about what's going on, and we can manipulate these different files and folders. If we want to get rid of them, we can simply use the command rm for remove. So let's start with that file 4 in the documents folder. For anyone wondering why sometimes the names I'm giving tends to jump quite fast, be aware that you can use the tab command to auto-complete the folders and the file names you've got. So if I hit F and then the tab key, it will auto-complete because there is only one file that begins with an F. It makes typing and interacting with the terminal much easier, much faster, and much less likely to have spelling mistakes, which happens to all of us. But if I now have that RM, and let's just list everything within every folder, we can see in my documents folder that has disappeared. Okay, that's now gone. Everything's been removed from the documents folder. It's either been moved out of it or it's been deleted. Now, in the same way that we moved wildcard characters, we can use that wildcard to delete files as well. So let's have a look at, I'm going to change directory into folder 1 just so that we can focus on that for the minute. We've got 2 txt files and 3 just generic files. If I want to delete everything that's a .txt, I can use our wildcard character again. I can turn around and say, I'm removing everything that ends with .txt, and we can see those files are gone. So lots of different ways that we can interact with different files, lots of different capabilities that we have. Anything you can do with the GUI, with that graphical interface, you can do on the command line, even if we wanted to completely delete the folder. So let's go back up to our home directory, and let's delete folder 1. So if we want to delete that folder 1, we can just run this rm-r because it's a folder with contents in it, so we need to recursively remove everything. Folder 1. And when we run our ls command, we see that folder 1 is gone. Once again, there's no are you sure, there's no confirmation. It is trusting that if we are using the terminal and we know how to interact with Kali through the command line, that we know what we're doing. So that's really important. That's a really important concept, that it will let you delete sensitive files. It will let you overwrite sensitive files. Just be aware of that and be careful with that. One thing to also be aware of when we're thinking about folders and files is that as much as the ls list command is showing us the data available, there are hidden files within the folder structure. If we type the command ls-la, which we can think of as a listing all, we can see that what happens is we get a lot of files that start with a dot in front of them. Okay, we can think of these as essentially being configuration files. These are files that you don't want to be able to accidentally edit. These are folders. Again, we can see here it's a folder of .config. We don't want to be able to accidentally overwrite these. We don't particularly want to see them most of the time because they're not the files that we are creating and making and editing. These are much more along the premise of system files that are configs. And we have the ability to interact with them in the same way that we can interact with other files. So if we take ZSHRC, which is the configuration file of our ZSH shell, we can open that file by typing it out and see that here is the content of that file. So we can absolutely interact with them as much as we want. It's just that, for the most part, these are files that are not necessary for our day-to-day activity within the operating system within Kali. Okay, so let's clear this and let's talk about users and privileges. Okay, so just like Windows has user accounts and administrator accounts, Kali is a Linux distribution. There are user accounts, and there is what we call the root account. Root is the highest level of privilege on a Linux machine. And if, as you go through penetration testing, you hear people refer to the idea that they have rooted a machine, it just references that idea that they have got to the highest level of privilege on a machine. Now, when we're talking about this, what we mean is that different users have the permission to do different kinds of activities on a machine. And like everything, you don't want any user on a computer to just have the permission to do whatever they want. So we are the user account Kali. We can see that with this reference here. And I can run the command, who am I, to see that this is my user account. And that's all well and good. That shows me what level of account I'm running. That shows me which account I'm actually using. But we have the ability to escalate up to root by running the command sudo su. So you can think of sudo as a super user do, and we want to escalate to the super user. So as long as the user account we're in, Kali, has the permission to escalate its account up to root, we can hit enter here, type in our password, and we can see that the prompt now changes to say, we are root here, we're running as root. And it's really important to be aware that, just like mentioned before, Kali is not going to give you any "are you sure you want to do this" kind of warnings if you start to modify files that are required for the system. If you run a command as root to delete something that is incredibly important to the operating system, it will delete it, and then you will just never be able to boot your computer back up again. Okay, so be really careful when you're running commands as root that you are running the actual command that you want, and that you're not accidentally editing, modifying, or deleting a file or a folder that's important. So let's go back down to our user account. We can hit exit and drop back down to Kali, and we can have a look at a demonstration of this different level of privilege. So on a Linux machine, there is a file called the shadow file. Now, when we log on to any computer, our password is hashed and stored on the computer, so that when we type in our password, the computer will hash our input and it will compare it to that value to confirm we are the user that we want. This means that the file that stores these hashes is incredibly important. It has the hash of everybody's password. As a penetration tester, if you can get to that file, you can take everybody's password hash and then try and crack them. So you don't want just every user to be able to access that file. So if we see if we can open it, let's just run the cat command. We're going to try and open the shadow file in etc shadow, and we get this permission denied. Now that's good. We don't want users to be able to open it. We can either escalate up to root with sudo su and run this cat command, or we can just say, you know what, I would like to escalate my privileges and run that again. And you can see this time I get the ability to read the file. For awareness, this is the password hash of my Kali user account. You can see here is my user, here's the password hash. As a pen tester, I might try and crack that. If we scroll up, we can see there is a root user. Our root user on this machine actually doesn't have a password hash, and that's really good because that means that no one can log in with the username of root and a password. You have to log in as a normal user and then escalate up to root if you want to do something that requires a higher level of privileges. We can also have a look at some of this data from here to see what kind of software is running on this machine. We can see I've got some kind of web server potentially running on this machine. I'm likely to have SSH running on this machine. We're going to talk about these later, but we can see that this is where user information is stored, user hash information is stored, so those password details, and that only the root account has the ability to do that. So when we're thinking about different user accounts, we don't necessarily just have one user and root on a machine. We might have multiple users. So let's talk about how we can create them. I can create a user account by running the add user and giving a username. I need to do this as a higher level of privilege because the part about creating this account is going to require me to have a password. It's going to require that password to be hashed, that hash to be stored in the shadow file. So I need a higher level of privilege to be able to create an account. So I'm just going to give myself the password of password. We can just ignore all that. And now, if I quickly have a look in the home directory, you can see there is a folder there for the user Dan, and that user now exists. If I want to change from one user to another, I can just use the su command to go to a different account. Okay, I will be prompted for the password of Dan, and if I know it, I can change to Dan. We can see that I am now the user Dan. Importantly, the folder that I'm in has not changed. You'll note this is showing the tilde because I am in the home directory of the Kali user. Now it's showing the full path because I am the Dan user account. So when it comes to user permissions, I'm now the user Dan in the home folder of a different user. And we can see that now when I try and list these files, I get permission denied because I don't have the right permission. I'm not the right level of privilege. Okay, we're going to talk about how permissions link with privilege in a minute. But for the moment, we can see that different users can't necessarily see each other's files unless the computer has been configured that way. Now, we can also look at the fact that not every user has the ability to escalate to root. If I try and run the same command as earlier, that sudo su command, I can type in my password and see that Dan is not in the sudoers file. So that means that the user account Dan does not have the permission to be able to escalate to root. That user has not been configured to be able to get to the level of privilege of root. Whereas if I exit back to my Kali user, we can see that Kali does have the ability to escalate to root. So how do we know what permissions our users have? How do we know whether or not we've got that level of capability when we get onto an account or when we're looking at a user? We can run the sudo -l command. So think about it as super user do list. Give me a list of what I am able to do. And we can see that in this instance, it's quite clear. User Kali may run the following commands on Kali. And it's showing us this all. Now what that means is that the user Kali can run commands as all users and all groups. We can group users together if we choose to. And it can run all commands. So the most important thing here is that the user Kali has the ability to run all commands. This bit outside of the brackets is telling us what commands can this user do, and it can do those while running at the privilege level of all other users in all other groups. If we go back to our newly created Dan account and run the same command, sudo -l, we can see that it simply says you cannot run sudo on Kali. You do not have the permission to do this. So when we're thinking about privileges and user accounts, it gives a very clear view about which users have the ability to run what kind of activities. Now, this is something that is able to be changed. Okay, if we have the right level of privilege, we could add Dan to that sudoers file that has been mentioned. And let's take a look at that. Let's go back to Kali, who has the ability to look at it. We can look at nano etc sudoers. This is the sudoers file. Okay, it's got a lot of data, but we're going to scroll all the way down to the bottom for ease and just an introduction to this. And we can see this bit here at the bottom is where it is showing which users have the ability to run what commands. So we can see here this use of all, and all, and again here, all, and all. So what we can see here is that we've got information about user privileges and information about group privileges. And we've got that all again. So let's break this down. Where we're looking at this user-specific privilege, we've got a username here, root. So the root user has all permissions here. So this first all means in all terminals. Any terminal on this machine, on this host, root can run as all users in all groups and can run all commands. What we've got below is a group. So we've got a group called sudo. So instead of having to turn around and manually put all of the different individual users in this file, we could manage them in a group, what we call the sudoers group. And the percent symbol shows us that this is a group, and it's telling us that anyone in the sudoers group can do the same. In all terminals across the host can run as any user in any group all commands. The most important bit is this last bit here. What commands is a user able to run with sudo privileges? Okay, so when we're thinking about how we can control privileges, we can add users to this file, or we can add users to a group. Let's go back and prove that Kali is part of the sudoers group, because Kali is not in this list, but clearly has the ability to run this command. Okay, so we can run groups. Kali is in all of these groups. Kali is in the sudo group. Okay, therefore, we've got that reassurance that Kali can run commands at a higher level of privilege. We could also query the groups themselves. Instead of having a user and asking what groups is the user a part of, we can look at the group itself and ask what users are a part of that group. And that's simply catting the etc group file. And if we scroll up, we can see, where is it? Sudo, here we go. We can see here's the sudo group. Kali is a part of this group. And just like before, you can see there are other groups that Kali is a part of. These are less important for us. This sudo group, these are where we're finding out which users are part of this group. So what do we do if we want to give our new account, Dan, an ability to actually run commands as sudo? Well, we could either add him to the sudoers group. Okay, that's one option. And we can do this by simply saying, I want to modify a user, add a user to a group, the sudo group specifically, and I want to add Dan to it. If I hit enter here, Dan will be a part of that sudoers group and will then be able to run sudo su, escalate to root, or run sudo and any command afterwards. But let's say we wanted to have a little bit more control than that. We don't want Dan to just have the ability to do anything that we want. We could edit that sudoers file. Let's edit that sudoers file. And we could add Dan to a hard-coded level of capability. So we can go here and we can just say, I want Dan in all terminals to be able to run at all users. But I might not want Dan to be able to do too much. I might just want Dan to be able to run the command cat and open a file, but not necessarily be able to modify it. So we would turn around and say, this is the function that I want Dan to be able to run, the cat command. Okay, what this is doing is saying only this command. Remember this last bit here, this is saying all commands can be run. As root, all commands can be run. This is saying only this command is able to be run with root privileges. So let's save this and demonstrate that. Now Kali is in the sudoers group. So Kali can run cat, and let's look at that shadow file again. But Kali can also run something like nano, and look at that shadow file, and start editing this if it wants to. Has the ability to overwrite data if we wanted to. If we jump over to our Dan account, Dan has the ability to say, I want to open that shadow file. I want to be able to read this data. But if Dan wanted to do something like overwrite somebody else's password hash, that is not going to be possible. Dan does not have the ability to run the nano command. Dan does not have the ability to turn around and run sudo su and just escalate up to a root shell. So privileges can be controlled in a very, very granular fashion, and we can turn around and make very clear that some users can do everything they want. Some users can do very specific tasks. Some users, we could just turn around and go, you know what, you are a generic user. You do not have permission to do anything. But what we've always got to be really important of is that idea that anything that is running at a high level of privilege, anything that's running with that root level of privilege, has the potential to do real damage. So lastly, let's just have a look at that root account. If we run sudo su, we're at root. Root does not have a directory in the /home directory. If we list this, so if we list the /home directory, we can see that both the user accounts on this machine have a directory here, but root has its own folder over here. Okay, it's got the /root directory. It can put whatever files it wants here, and no one would be able to read it unless they had that root level of privilege. Okay, next we're going to talk about Linux permissions. Let's just clear the screen so that we can look at permissions and get a good understanding of the topic. So I've downgraded myself back to a Kali account, and we're going to run the ls-la command to show all the permissions that exist for the files and folders within our home directory. Okay, we can see that what we have is this kind of string on the left-hand side, which is telling us what are the permissions on this file, who is the owner of the file, and what is the file. So if we go and have a look at our folder 2 folder that still exists, we haven't deleted that from earlier, we can look at these files by running ls-la, and we can see that we have these permission strings here. So what does this mean? Well, we can see we've got the name of the file on the right hand side, and on the left hand side we've got displayed which user roles have what level of permission to access this file. And then we've got this part here, again, the owner of the file. These are all owned by Kali because Kali is the username that created them. So that is the owner of the file. So to be able to really explain this left-hand side of this R and W and these hyphens, we're going to move over to PowerPoint quickly to just be able to explain this topic a little bit easier. So when we're looking at this strange string of text, what we're actually seeing is we're seeing which users have read, write, and execute privileges over a file. Okay, so when we run the ls-la command, we see a long string, and we first of all get a hyphen at the front, this here, that tells us if something is a directory or a file. So if it's a folder, this will start with a D, the directory. If it's a file, like this example on the screen, file.txt, then we will just have that dash, that hyphen. What we've then got is an understanding of whether or not different users have read, write, and execute permissions to a file. And they're self-explanatory when you think about them. Read permissions means that someone can open this file and read it. Write means that they can open a file and make modifications to it. And execute means that if it's a script, if it's a command, if it's something that actually is a tool that executes an action, execute means that a user has the permission to be able to run that tool. And we see here we've got read, write, execute, read, write, execute, read, dash, and execute. What this is showing us is which users have what level of permission. And it's always in a specific order. The first read, write, execute, or the first three dashes are the owner of the file. So we can see, this is the user that created the file. This is their rights. So Kali, in blue, Kali is our user that created the file. Kali has read, write, and execute permissions to file.txt. This is pretty standard. If you create a file, you want to be able to do whatever you want with it. Okay. Then we've got the group. So we've got group rights. And we can see that anyone in the Kali group of users would have read, write, and execute permissions as well. So that's our second set of permission letters. And then the third lot is everybody else, so everyone else on the machine. And so this means that the Dan user that we've created on this machine would have read access to this file, would have execute permissions on this file, so if it was an executable, could run it, but does not have write permissions, so cannot modify this file. And again, this is very standard. Because when we create something, we might want other people to be able to read it. We might want other people to be able to run tools that we've created, but we don't want someone coming in and making changes to our file, overwriting what we've done. Now, when we start using Linux in a minute to be able to change the permission levels, we're going to use a numbering system to tell Kali what level of permissions should be applied to our file. And this works in, again, an easy way. Once it's explained to you, it's easy to get your head around it. It's just simple binary. We have three values: read, write, execute. In a base 2 numbering system, they have the values of 4, 2, and 1. So when we are assigning privileges to a file, we just have a 3-digit number that will say, what are the permissions of the owner of the file? What are the permissions of the group? What are the permissions of everybody else? Quite commonly, you'll see permissions like 755. So 755 would mean the owner of the file can do whatever they want, and literally everybody else on the machine can either read the file or execute it. We might see things like 644, which would mean it's a non-executable file. So for things like a text file, 644 might be something useful where we're saying the owner of this file can read and write to this file, and everybody else has the ability to read this file. But there's no need to give the executable permission because it's not an executable. So let's jump back to Kali and explore this. Read and write permission to this file. The permission level they need is 6. So I'm going to just give everybody read and write permissions. And now if I run that ls-la command, you can see that this has changed. It's saying that the everyone group, this last few characters at the end, now have read and write permissions. And if we go back to this terminal here, I can edit this to say whatever I want. Dan edited this file. So that is a user being able to modify the permissions of a file they control. Okay, what happens if we want to give something some kind of executable permission? Well, let's first create a file that we want to run. So in our temp directory, let's do a simple hello world kind of script. So we're going to do hello.sh, really simple bash script. So I'm going to put the shebang at the beginning of the file. This is called a shebang. This topic, it essentially tells the system that this is a bash script. It makes sure the system understands what it is that we're doing. So I'm going to have this echo out hello world. Okay, that's all it's going to do. It's a really simple script. Now, if we look at the permission levels on that file, we can see hello.sh at the minute just has read, write, read, write, read. We cannot run this file. If I try and run this, you will see that this does not execute. It says permission denied. Okay, that's because essentially the computer doesn't know that this is an executable file. We don't have the permission to execute this. So we can once again modify the permissions, and we can either add 1, we can either give it a 777 permission, or we could just turn around and say plus X, so make this executable for everyone. And now, when we look at the permissions, we can say that this one is now giving read, write, and execute permissions, read, write, and execute permissions, read and execute permissions. So now I can execute this as Kali, and I could also go and execute this as Dan, because again, the permissions say that everybody can execute this. If I wanted only the Kali user to be able to execute this, I would simply need to modify this part here. I'd need to make sure this was not giving executable permissions to all other users. Remember that last 3 characters are for everybody else on the machine. So I could chmod this to say, you know what, no one but the owner of this file can do anything with it. This doesn't impact my ability to run my script at all, but it means that should anybody else on this computer try and run it, they will get a permission error because I've been able to set this properly. This is important when it comes to things like system files. If we really quickly go and have a look at that shadow file that we saw earlier, we can run ls-la for shadow. Let's have a look at just the permissions for that. We can see root. Root is the owner of this file. The most important bit of information when looking at this data is who is the owner of the file, what permissions do they have. This is why only root can read and write to this file. Anyone in the shadow group can read this file and nobody else can do anything else. Okay, this is why Kali cannot cat this file. Okay, we will get permission denied. But if we run sudo cat shadow, then we are using that sudo command to escalate up to root privileges, and root has the permission to be able to read this file. So, really important concept, easily able to change. If we own the file, we can change the permissions. If we don't own the file, but we can escalate up to root, then we can change the permissions of any file on the machine. Can cause problems if you start changing permissions of different files that are important to the computer, so just be aware of that, and hopefully you won't break anything. Okay, let's look at networking. Let's clear the screen. We're going to move back to the home directory just to make sure I don't accidentally create a file somewhere where I don't want to. Okay, so let's talk about networking. Networking is a very important part of computing as it allows computers to communicate with each other, and it gives us the ability to access networks like the internet. However, it can be a bit intimidating to look into networking on a Linux machine, as most of it is controlled through the terminal, through this command line interface. So let's jump in and figure out how we can explore this topic. Let's first look at our IP address on a machine. On a Linux machine, we can get our IP by typing IPA. This means IP address, or this is showing me all the IP addresses that I have on this machine. And we can see we have number one is a local IP address, this 127.0.0.1. This is the local loopback IP. If ever anything and any machine is communicating with 127.0.0.1, they are communicating with themselves. This one, we don't use this for any kind of networking capability. This is my IP address, 192.168.10.134. It is on a /24 network. What that means is that every machine on this network is going to start with 192.168.10. If you're not familiar with network masks, don't worry. That's a whole other topic in itself. We're not going to talk about it too much in this video, but it is something to be aware of, and we will cover it in other videos. So, if you'd like to follow along with what I'm going to do, we're going to make just a few configuration changes to this machine that I recommend you follow. This IP address, 192.168.10, is not the same IP address that my wireless network that I'm connected to uses. And that is because there are a couple of different ways that VMware and virtual machines in general can sort out networking. What they can do is they can use a concept of NAT, network address translation, where my virtual machine is essentially using my computer as a router, and it is routing traffic through my computer. So it doesn't matter what IP address I set for my virtual machine, because it's going to route all its traffic through my physical computer, and that is connected to my wireless network that can go out to the internet. What we're going to do is we're going to change this virtual machine so that it is on what we call a bridged interface. And what that means is instead of using my computer as a router, my virtual Kali machine is going to be just like any other computer on my Wi-Fi. It will talk directly to my Wi-Fi router as a way of getting out of the network. So just going to really quickly change that. I'm going to minimize this. To change it, we're simply going to go to settings here. We're going to right click the name of your machine, go to settings. We're going to look at this network adapter option here. You can see it's currently in NAT mode. we're going to change it to bridged mode. And then just hit OK. To put this full size again. So to be able to get our computer to make sure it gets a new IP address, we're just going to run the command sudo dh client. This is essentially a command to turn around and say, hey, go get me a new IP address from whichever router I'm supposed to be able to talk to. Now, if I run IPA again, you'll see that I now have a different IP address. I now have 192.168.1.94. So while it may look like a small change, this is fundamentally a different network, and I am now on my wireless network. I can now talk to my wireless router as a way of getting out of this virtual machine, as opposed to talking to my physical computer and having that relay my traffic to the router. So let's have a look at that. Most routers live on .1 of their network. So let's see whether or not we can communicate with the router. Ping is a command that is used to be able to see whether or not we can communicate with the machine, and we can simply type ping 192.168.1.1. So what this is doing is it's sending a packet to my router to say, hey, are you there? Are you receiving this? And it's getting a reply. Now, if you've done this on a Windows machine, you'll know that Windows sends only 4 of these packets and then it stops. On Linux, we don't do that. We send packets until we're told to stop. So you're going to have to hit Control and C when you're ready to stop sending packets. It's really important to remember that. Otherwise, you can end up having multiple terminals open, pinging multiple machines, and they're just going and going and going, and you're steadily using the resources on the computer. So that's our wireless router. But you might ask, how do we know that that lives on 192.168.1.1? Well, let's have a look at the routing table. Okay, routing tables are ways that we can figure out how is our computer able to get out of the environment that we're in. How are we able to go from our wireless network to Google? What we can see is that we have what's called a default gateway here. This default gateway is on 192.168.1.1. And this means that anything not on my wireless network that my computer can't immediately speak to, it will turn around and say, hey, I don't know where this machine is. It's on an IP address that's not on my network. How do I get there? And that is why it's important to be able to have a default gateway. If we were to remove that gateway, or we did not have a gateway in our routing table, we would not be able to communicate with anything outside of our network. Now, luckily, most networks work on a concept called DHCP. This is where a router will automatically give any computer connecting to the network an IP address. It will tell it a default gateway, and it will give it what we call a name server to use. So name servers are how we can turn around and understand, what is google.com? Where does that live? Where does youtube.com live? What are their IP addresses? Because we can turn around and say things like, well, I want to ping www.google.com, and we can get a response. We can see here that we're getting details of an IP address come back to us. And that works through the concept of using a name server. Okay, so name servers are the systems that we use to translate a human readable name like this into a machine understandable IP address like this. Within Kali, within Linux in general, the details of what name server your computer should use are in the etc resolve.conf file. So we can see that my computer is currently configured to use my router as a name server. But we can change this. We could do, we could set this up however we want. These are the default configurations that I get whenever I connect to my wireless network, because any machine that connects to my wireless network will be given this information by the router. It will be told, here are the rules of interacting with this network. Here is the information that you need to be able to communicate in this environment. And that's great for the most part. But what happens if we don't have DHCP? What happens if when you connect to a network, you're able to connect, but you don't get an IP address? This is what we call a static network. It's what a lot of data centers use. It's what a lot of some potentially larger corporate environments might use if they're much more structured and they're less focused on people connecting and disconnecting machines consistently. So we can find ourselves in an environment where we're trying to conduct a test, and when we connect to the network, we don't get given an IP address immediately, and we have to configure that for ourselves. So let's have a look at how we do that. It's referred to as the concept of a static IP address as opposed to a DHCP IP. When you connect to a network and get given the data, it's a DHCP network. When you connect to a network and you don't get given that information, it's a static environment. You have to set a static IP address. So what we're going to do is we're going to have a look at how we can set that up ourselves. First of all, what I'm going to do is I'm going to remove my IP address. And we can now see that my ETH0 interface has no IP. It can no longer ping google.com. It can no longer ping 192.168.1.1. We can see that it just has name resolution failure here because it doesn't know what name server to talk to, network unreachable here because it doesn't know who 192.168.1.1 is. It doesn't know that I'm on that network. So the way we use this and the way we can configure our machine to be able to still interact with an environment like this is that we just manually set those details into the computer. So to clear the screen, figure out how we do that. To set an IP address for your machine, you need to know what IP address range you should be working with. And we can just type sudo IP address add 192.168.1. I'm going to pick 200 /24. And I want that to connect to the device ETH0. IPA. My computer now knows that it should use the IP 192.168.1.200. Now I picked 200 because it's a suitably high IP address that I'm sure I'm not going to be essentially trying to take or claim the IP address of another machine on my network, which is always a concern when you're using static IP addresses. But I'm quietly confident that nothing is connected with that IP address. Now I can try and ping other IP addresses again. We can try and do that concept of pinging 192.168.1.1. And this time it works because my computer understands that it is in this network range. Okay, every computer on this network is going to start with this 192.168.1. So my computer now understands that it can talk to other devices on this network range. If I try and go back to pinging www.google again, we'll see that I still can't ping that. I still don't know, I still don't have information of where that is. Okay, I'm still not getting enough data. If I try and pick a machine on the internet that I can try and ping to see if I have internet access, I can do that. If you're ever interested to find out if you have internet access, I recommend always trying to ping 1.1.1.1 or 8.8.8.8. These are the name servers used by Cloudflare and Google, which means that they're pretty much always going to be up and responding. They're good IP addresses to use if you ever want to be able to figure out can you talk to a network? Can you talk to the internet? So we've been able to give ourselves an IP address where we can turn around and say, I'm on a network. I want to be able to talk to other devices on this network. What if I want to be able to get out to the internet? I can run the IP route command, and I can see that there isn't any default gateway. There's nothing telling me what's to do when I'm going out of this. All this is saying is that my machine has the ability to talk to the entire network. So I need to be able to set a default gateway. And I can do this by turning around and saying, I want to use the IP command to set a route. And then I'm going to add a default gateway via, make sure there's a space there, via 192.168.1.1. And now if I run that IP route command again, I can see I've now got this in a default via the 1.1 IP address. This means that if my computer is trying to talk to an IP address that's outside of this network, it should go through this IP address. This is my router. So now if I try and ping 1.1.1.1, we can see that I now get a response. I'm now able to communicate out to the internet, which is great. I've now given myself the ability to connect to this network, to set a gateway to get out of this network, and I can talk to the internet. But let's see whether or not I can do things like pinging www.google.com. We see that I can, and that's because when I've set my IP address up, it's been able to talk to the wireless router and grab a name server from that. I wasn't anticipating that. So let's go have a look at how we can configure a name server itself. So if we, as sudo nano etc resolve.conf file, we can see my root has just helped itself to saying it's a name server there. I'm going to delete that, save it, so that now if we look at what happens when this resolve.conf file doesn't have anything in it, can I ping google.com? This will fail. It's that failure in a name resolution. It doesn't know what computer to go to ask who is the name server I should talk to. Now I mentioned, 1.1.1.1 is a name server, so is 8.8.8.8. We can simply add those details to our resolve.conf file. I can turn around and say, the name server I want you to use is 1.1.1.1. Now you can add multiple name servers here. I can turn around and say, if 1.1.1.1 is not available, go to 8.8.8.8. And once more, if I try and ping google.com, this will work because it knows who it's going to get the IP address. Okay, so the eagle-eyed among you may have spotted that there are different IP addresses coming back from Google. That is purely because Google has obviously a lot of IP addresses, and it is translating the name of different machines. We can see here the first time I translated Google into an IP address, it got this host name and this IP address. The second time it got this host name and this IP address. There's nothing wrong with that. Realistically, I don't care what IP address Google has. I just want to be able to open up a browser and know that when I type google.com into the browser, that I'm going to be able to get that name resolution. This can be a really simple way of bypassing blocked websites. When you turn around and have an organization that is saying you can't go to different IP addresses, you can't go to different websites, some of what they might do is set this on their name server. They might turn around and say, if someone is trying to go to facebook.com, snapchat.com, you're going to redirect them to this blocked website, webpage. That is because you're talking to a specific name server that has that information. Whereas if we reconfigure who we are asking for an IP address, we may be able to circumvent some of this really simplistic kind of network filtering. Now that we've got our networking set up again and we can get to the internet, let's clear the screen. And what we're going to have a look at next is how to install tools. What we're going to have a look at is the tool Git. This will allow us to go and get more software from the internet from GitHub, a well-known tool repository. So I'm going to just show you what happens when you try and run a command that is not installed on your computer. So you've got the command git. This is not found, but can be installed. Now you can either run sudo apt install git, or you can just hit yes, and it will run the command for you and ask for your password. This is a common way to go and install software. If you want something installed on Linux, you just apt install that software. And we can see that with Git, we get a prompt to say, do we want to install everything? Do we want to make the changes? And we just simply hit Y and say, yes, I would like to do that. This all runs through pretty automatically. Some software will have a prompt to say some services may need to be restarted. Is that okay? And for the most part, you can just think of it like the process on Windows of the installation graphic, where you just have to hit next and yes, and I agree. But for the most part, as soon as you say, yes, I'm happy, make the changes, and continue the installation, the tool will go and install. There is Git installed. Now, if I run the command, we can see it's installed. It's asking what I want to do. It's happy to be able to run and install. And that's great. So why have I used Git as the tool to demonstrate this with? That's because there is a great website called GitHub that you may or may not be familiar with that hosts a lot of tools that people create. Some of it is incredibly useful, some of it might be very niche, but being able to go and get a tool from GitHub is a valuable skill to be able to have. So how do we do this? Well, we use the git clone command. And what we can do is we can simply go to a GitHub project, see what this is. So we're going to look at learning Linux. This gives a range of challenges and tasks for you to do after you've gone through this video. So it queries your ability to run commands. It gives you challenges and tasks to be able to demonstrate you've learned how to use Linux. And what we can do is we can go and just copy this link here. So I'm just going to copy this. And I can go and download this. I can clone this onto my machine. Now, when installing software on a computer and when git cloning, which is what we're going to do, you can put this anywhere on your machine, but it's always good to have somewhere where you try and put everything you're installing. So as we mentioned earlier, opt is a good place to be able to install software. So I can just simply git clone, paste in that URL, and this will, and this will go and get me that project from GitHub and be able to put it on here. This sudo exclamation point is a command to say run the previous command, but with sudo privileges. So instead of having to retype out the command, I can just type sudo exclamation point. So now when I look at this folder, I can see that I've got learning Linux and I've got all of the content from GitHub. Okay, I've got my shell script, I've got a PDF, I've got a README, I've got information there for this script. Most people who host things on GitHub and use that to share their tools and share their work will turn around and give the instructions on how to install and how to run these tools on your machine. And for us, we're going to go ahead and see how do we, once we've downloaded something from GitHub, once we've cloned it onto our machine, how do we run this? I'm just going to simply use the knowledge that we had earlier of permissions. I'm going to make that script file executable. And now I'm just going to run that tool. And we can see that is how easy it is to be able to get a tool from the internet, get it onto your machine, and be able to run it. You just simply need to know where the tool is, run a git clone command, and be able to put it on your computer. We're going to go through some of these challenges and some of these exercises a little bit later, but if you go and get this tool, that PDF, learninglinux.pdf, takes you through a range of different challenges for you to go through to really try and test whether or not you're able to use Linux effectively. And it's not a test, it's just giving you a bunch of different activities to try and focus on. Okay, so let's head back to the home directory, just because that makes sense to sit there. So being able to download, install, run tools, that is really helpful. That's always a useful thing to have. Before we go into some miscellaneous commands, before we go into playing around with that Learning Linux tool and being able to see how we can just generally become more proficient in our command line capability, what I want to talk about lastly is services that run on our machine. So when I mean a service running on a machine, we have a lot of power over a Linux device. We can turn around and run SSH to allow people to connect remotely to our computer. We can run web servers on our machine to allow us to be able to access different files that we can put on a web server so that we can host something that either shares our files to another machine or gives someone a landing page to come and look at. We can do a lot of different things on this machine. We could host databases if we wanted to. They are all referred to as services. And what we can do is we can start and stop them. We can configure them to be able to start on boot of our machine, and we can use them for a couple of different purposes. So let's have a look at one of the most common services that we tend to use when it comes to accessing Linux machines, and that's SSH. So I'm just going to clear this screen quickly. And we're going to think about SSH. Now, SSH runs on TCP port 22. Some of you may be familiar with ports, some of you may not yet. That's absolutely fine. But I'm going to really quickly show you that my port 22 on this machine is not open. Okay, so what this is doing, this is a tool called Nmap. It's a network mapper. It's a port scanner. It's going to look for the TCP port of 22 on my computer. This is a key tool for penetration testers, and we'll go over that in future videos. But for the minute, the key thing to be aware of here is that this port is not open. Okay, we get this closed bit here, meaning that if I try and SSH onto my own computer, SSH Kali at 127.0.0.1, I will be rejected. Remember, 127.0.0.1 is my machine, so there's no restrictions on being able to get to that computer. It's that SSH is not running. And we can confirm that by turning around and saying, okay, I want to do a command saying systemctl status SSH. And this shows that this is disabled. It's not running at the minute. If I turn around and say I want to start this service, then what happens is if I now check the status, I can see that it is active. I have essentially turned on the SSH server on my machine. For anyone not familiar with what SSH is, it's a secure shell. It allows people to be able to connect to a computer from the command line from a remote location. Okay, so we can see that SSH is now running. What I'm going to do is I'm going to quickly move out of this user account so that you can see the difference. I'm going to just move to root, actually, to be honest. So let me just escalate up to root, just to make it really visually clear that I am remotely accessing this machine. So I'm now root. I'm going to cd to the root directory. Okay, so it's very clear. I am now the root user in the root directory of my computer. Now that I've got SSH running, what I can do is I can SSH into Kali, the user that I would like to log in as, on this computer, 127.0.0.1. It's saying you've not connected before. Are you sure? Saying yes. I can type in my password for Kali, and this will try and log me in. Okay, and you can see now I have this prompt. I am Kali on this machine. If I look at my present working directory, I'm now in the home directory of the Kali user because this is who I have just logged in as. So SSH as a protocol is the secure shell protocol. It allows us to log in to Linux machines through the command line. So this now is technically a completely separate connection from the terminal that I'm in. If I type exit, this isn't me turning around and going, oh, I'd like to escalate back up to root. This is me saying, I want to shut down my remote connection to this server. And now I'm back as root in this terminal. So it's about being able to connect back to things. But the premise being that this is a service that we can turn on and we can turn off. So I'm just going to get myself back into my Kali user to make sure I don't accidentally delete or edit anything. And we can do this with other services as well. A good example would be web servers. I mentioned that previously. So let's go back to Firefox. Let's look at 127.0.0.1, my local machine. We can turn around and say, am I hosting a web server on this machine? You can see we get, an error occurred. No, nothing is being hosted here. And that's because if I then run sudo systemctl status Apache 2, I can turn around and say, okay, well, now I know that the web server Apache 2 is disabled. So same as I've done with SSH, I can just turn around and say, you know what, I would like to start this. And when I go to Firefox, I can simply reload this page. It's an HTTP server, so just be aware of that. I can't connect over HTTPS. And now we can see I've got a web server running. This is running a default page, but it's running. I can go and put whatever I want on that. Okay, this is data that is being stored in the cd www folder and in HTML. So if I quickly list out this index.html, this is that file. If I quickly move that, so let's move index.html to index.html.back. I can create a new landing page that this machine will show. So let's just do a really simple HTML h1 demo. And now, when I go and refresh this page, we'll see that the content will change. Okay. The premise very much being that your Kali machine is powerful enough to do a lot of different things, and it can run different servers that can give you the ability to remotely connect to them. It can give you the ability to host files on a web server that can be able to be used to download. It can give you capability to do a lot of different things. Now, when we reboot this machine, these will turn off, and they won't come back on a reboot. But if we wanted this to always be turned on as soon as we boot up the machine, then we can just run the command sudo systemctl enable, let's do Apache. And what this is doing is it is turning around and saying, okay, change this as a setting so that as soon as this computer is turned on, the Apache server is enabled and it is active and it is running. And that's how we can use services on our machines. We can simply install what we want. We can go and install a web server, install a MySQL database, anything that we want, and we can set it up as a service that people can interact with and people can connect to. So I'm just going to clear my screen, and we are going to start talking about how we can use some miscellaneous and key kind of Linux commands to be able to be effective Linux users, to have an effective experience from the command line. Now that we're familiar with some key areas of Linux and how the operating system works, what we're going to do for the last section of this video is give you a bit of exposure to some really common Linux commands that can be helpful and give you that kind of experience in being effective at using the command line. For anyone who wants to follow along with this video, I highly recommend at this point you go to the North Green GitHub page and get a copy of the Learning Linux script, because that's what we're going to use to give us some examples about key activities, key commands, and key kind of concepts that you may have to interact with, that you may not have to be familiar with when it comes to using Linux. So we are going to change directory to the opt directory. Earlier on, we used git clone to get Learning Linux. So I'm just going to change directory into this folder. And I have the Learning Linux shell script here. So I'm going to run this with root privileges. So sudo Learning Linux. And this is going to give us a couple of different kinds of exercises. So first of all, let's look at how we can interact with data. It's really important that we've talked about how we can create files, how we can create folders, and how we can interact with them. But it's important when it comes to using Linux to be able to actually extract valuable data from files, especially as a penetration tester, because you're going to find yourself looking at dozens, if not hundreds of machines. You're going to find yourself with lots and lots of files that have huge amounts of data in them, and you need to be able to extract out the valuable information or the information that you're interested in at that point. So let's look at data exercises. Okay, what we're going to do is I'm going to open up another command prompt, another terminal over here. And we are going to cd into home, Kali, learning Linux, data exercises. This folder gets highlighted when you pick each option. So it's going to show you where the exercises are and where the data is. Okay, so we have two files here. When we're dealing with files of varying file types, of varying file sizes, we may want to know how big those files are. We looked earlier at using things like ls-la to figure out how large these files are. We can see that they are varying sizes. We can do cat fruit list, and we can run word count -l to see there are 100 lines of data in our fruit list, and in our names file there are 20 lines of data, and we may want to be able to extract useful data out of this. So if we first of all have a look at the fruit list file, this is a file that is comma separated, just like the CSV, but it's saved in a text file. And we have lines of varying length where we've got lots of different fruit, as the name would expect. What we can do is we can try and figure out every line with the occurrence of the word of one of these fruits in there. So for example, if we want to find every line that has the word cherry in it, we can use a command called grep. Okay, so what we can do, there are two different ways that we can use the command grep. We can either cat the file that we're interested in and pipe it to a command. What this single line is doing is it's called a pipe, and it sends the output of our command into the input of another one. So we can cat fruit.txt and use the grep command, which can be thought of like a search command, to look for the word cherry. And you can see our output is that it will go through our file and it will highlight every instance of the word cherry. Now the alternative way of using this would be to grep for the word cherry within a fruit list file, and this gives us the same output. But what's more useful to be aware of is that this output is only giving us every line with cherry in it. So if we wanted to extract only lines from a file that have data that we're interested in, be that ports that we're interested in a port scan, be that passwords that we're interested in that begin with a keyword, then we can use grep. And I can show you that this is only extracting those words by running this command. I'm going to pipe this to T. What this means is that I'm going to output this and save it to a file. Let's call it cherry. Okay, so now I can ls and see that there's a file called cherry, and if I cat cherry and check how many words are in there, how many lines are in there, sorry, see there are only 49 lines of data in there. So I've now been able to, with this command, I've been able to take an input file and go and get only the data that I'm interested in and output it to another file. And again, the usage of this in penetration testing may be that you only want to get IP addresses that begin with a certain number. You only want to look at users that are in a specific domain. It could be anything, but this is about being able to extract useful information. Okay, what else could we do? I mean, we could, for all we want, we could change the data in a file as well. Again, we've got a large file, it's 100 lines long, and we could turn around and say, you know what, I want to modify the content of this file. I want to do essentially a find and replace, but I want to be able to do this from the command line. So what I'm going to do is just really quickly copy this file, and if you want to follow along with the lab guide, this is, we've already jumped straight. Those few demonstrations have gone through the first couple of questions, and we're getting into now sort of question 5 of how can we extract out and copy and replace data that's useful. So let's take a copy of the fruit list, and we will create fruit list 2.txt. And what I'm going to do is I'm going to show you that this fruit list 2 does not contain any instances of the word peach. We don't. Oh, sorry, it does not contain any instances of the word blueberry. Okay, we don't have any instances of the word blueberry. We have lots of instances of the word peach. But if I wanted to take that word peach, find it, replace it with the word blueberry, how can I do that in the command line? Okay, I can do this using a command called sed. Okay, so what sed is going to do is it's going to find and replace the values within a file. So what this I is going to do is it's going to take my input file and it's going to make these modifications for me. And I'm going to turn around and say that I want to search for the word peach. Hang on. I want to search for the word peach. I want to replace it with the word blueberry. And I want it to find all of these globally. That G is global. So it's searching for the word peach, replacing it with blueberry, and doing it globally throughout this entire file. Put fruit list 2. Okay, so now if I run this cat fruit list 2 for blueberry, we can see that I now have lots of instances of the word blueberry. And if I grep for peach, there are no instances of the word peach. So this is a way that we can modify the value of a file without having to open it into a text editor, without having to do anything manually. We can just search for key names, and we can turn around, keywords, and we can turn around and change them. Okay, so let's have a look at the names file. Okay, so let's look at how we can get interesting data out of this. Okay, if we want to extract only the first names out of this, let's say we were interested in being able to figure out only the first names out of this file. We could first of all check, how many names are in this file. Once more, just really quickly, check how big it is. Okay, there are 20 different unique names in here. But if I'm not interested in that surname, I need to be able to remove that. What I can do is I can use the cut command for that. Now, the benefit of having this in a comma-separated file is that there is what we call a delimiter here. There is something signifying the difference between the first and the second name. So I can turn around and say, I want to cut this file, and I want to use a delimiter of a comma, and I want the first parameter. We can see that now all I get are those first names. But I might want to be able to turn around and say, okay, I don't want repeating names. I just want to know how many unique names are there. We can see here that we've got Paula here, Paula here. We've got some repeating names occurring. How do I make sure that I've only got unique names? What I can do is I can turn around and pipe this through sort and then U for unique, and it will only show me the unique names. You can see now, we previously saw Paula occurred at least twice. We now only have it once. And that's how we can extract useful data from files. We can just have a bit of a play around with that. So let's go back to the tool. Okay, so we've now got some compression files created, and we can see here that we've got compressed files in a couple of different ways. We've got a .tar.gz, a .zip, and a .gz. These all take ever so slightly different ways to be able to uncompress them. So first of all, we just need to check who has permission to be able to work with these. So we can only read these files, so we're not going to be able to unzip these as a normal user because they are owned by root. So we're going to run the command for number one, compress number one, sudo tar bxzf. And what this is going to do is it's going to extract this file, and it's going to give us an uncompressed .txt file. If we look at this, we can now see that we've got uncompressed.txt, and we can read that. Okay. When it comes to being able to unzip a .zip file, it's a bit easy to remember. We can just simply sudo unzip. Okay, and this one again, we can cat uncompressed 2. Hang on. Apologies, this one compressed an entire folder. So we can cd into home. This one has compressed the entirety of the Kali home directory. So learning Linux, compression. And we can see if we do this, we can see here is uncompressed 2.txt. Okay, so we can go back up. Remember, we talked earlier about being able to use that // to be able to go up one directory. We can do this several times, and we can get back to our compression folder. And we can look at this .gz file. A way that we can uncompress a .gz is that we can just run the command gunzip. And this one, again, it's going to give us, type on the tool, it's going to give us our compressed 3 file, and we've extracted this file. So there are a couple of different ways that we can compress files. There's more than this available, but here are some common ways that you may end up having files on a Linux system and how we can extract them via the command line. Okay, one thing that always comes up when it's about using the command line effectively is how do we find files? So if we jump into number 6 here, create files for finding files, then what we can do is we can jump into our file finding directory, and this will give us information about what files we need to find. Okay, so we've got 3 different files, unique file names. They're not going to be able to be found on the machine unless you've run this, because they're all just unique file names. And what we can do is we can have a look at a couple of different ways of finding files. We can run what we call the find command, obviously. We can say where we wanted to search. So we wanted to search from the root directory. We have no idea where these files are on our machine. And I can turn around and say, this is the name of the file that I want you to go and look for. I can remember that my keyboard is in the right format. So file1.txt. And we can see that what this is doing is it is searching through all the files that it can get to from that root directory, and it is looking for anything that is called file1.txt. Okay, it's going to take a while. We could give this a specific directory. We could narrow it down and say search through a specific home directory, search through a specific area of the file system. But because we don't know where this file is, and it could be anywhere, the tool will just put this somewhere on your machine. We need to search from the root directory. And if we just casually scroll up while it's doing its thing, we can see that it's trying to, it's trying to look at a lot of different places. So far, it's gone through the proc folder. If we scroll up, you can see it's looking through as many. Oh, I can't scroll. It's looking through as many different places as it can. This permission denied is not the end of the world for us. We're not too fussed about whether or not it can or can't get to them, because if it's only visible from the root directory, then we're going to struggle there. But it's going to go and have a look everywhere that it possibly can to see whether or not it can find our file. Okay, and we can see that it might take a little bit of time. You can see I've hit enter a couple of times while it was running, just to make sure it was still executing, but it is found in /temp file1.txt. And if we go and have a look, we can see there is file1.txt. Now this will run for all the different files that we can go and have a look for. It's one way that we can try and see what's going on. But as you can see, it takes a bit of time because it's going through the whole system. What we can think about is that there may be a faster way to be able to do this. There may be a way that we can rely on indexed file names, file names being indexed in a database to be able to help us find things at speed. So for example, if I show you that I might want to locate where bash is stored, I can run the command locate, and it just gives me every file that had bash. That command again was just locate. Now, this doesn't map every directory. Most notably, it will not look for things like the temp directory. But what we can do is we can make sure that the database of files is up to date. So we can run sudo update db, and it's going to take a little bit of time for it to turn around and just update its understanding of where files are and what is available and what they're called. And then we're going to move on to have a look at file 2, the comma separated value file. Let's have a look at that one. So we can now run locate file2.csv. And we get this reply really, really quickly. Okay, it's in the op directory, it's there. Okay, we can cat that, read that, we've been able to find it. Okay, so it's a really quick way of doing things. But what if we don't know what it's called? What if you're just told there is a file somewhere on here that you're interested in? Now I'm not going to use file 3 for this example because it's a log file and there will be lots of log files out there. But what I'm going to show you is that we can find this file 2 CSV file by searching for just all CSV files on this machine. So what I can do is I can just search for a file type that I'm interested in and see whether or not I might be able to get this file too. So I can again go back to that find command and say search everything. I want to find something that's from the root directory. But this time, what I want to do is I want to search for a file. This type F is saying what I'm interested in is a file, not a folder or anything like that, not a directory, an actual file. And I'm going to turn around and say that I don't actually know the name of this, but I know that it's something that's a CSV. And what this will do is it will go through and it will try and search for anything that is a CSV, and it will try and give me this information. And we can see here that it's been able to find, here we go, opt file2.csv. Now this is obviously getting a lot of information. We can see lots of other CSVs going by, even though I tried to keep it something where it's not too much data. We can see that there are a lot of other comma separated files here. So we can again turn around and think, well, let's just use some logic here. Let's use the grep command that we've talked about before, and let's just grep for file2 to show that we can do this. And we're going to have file2 is going to pop up in a second and show us that it is there. So there we go. Nice and in red, it shows us, yeah, here is our file2. We get the output of the command, but we get a nice indicator. This is what we're interested in. It's found our file, and it's been able to turn around and say, okay, this is what you're actually focused on. Okay, so let's go back to our home Kali Learning Linux folder. And now we've talked about how we can, so far we've talked about how we can create files, how we can create folders, how we can move them, how we can search for them, how we can get data out of them. And I've referenced things like SSH earlier on in this video. One of the things that we can have a look at is how we can copy files from one machine to another. How we can turn around and say, actually, I don't want to be getting a file on my machine. I want to go and get a file from a different computer. How can I share files or transfer them or go and pull them from another computer? So let's have a look at that, how we can do that. Let's clear the screen. we're going to go back to the Learning Linux tool. And what we're going to do is we're going to set up a Docker container here. What this is essentially another virtual machine. Containerization is a way of having very small files that essentially run as though they're another machine. Think of it just like VirtualBox or VMware, except you set it up with very specific requirements. You can set it up with, already with settings enabled. And what this has done is this has created a machine with SSH enabled, with a user account of root, and set the password as password. So what we can do is we can now log on to that machine via SSH, which means that we can then practice copying files to and from a completely separate virtual machine. So what I'm going to do is I'm just going to open up a new terminal, and we're going to use that so that we don't interrupt with the tool. Okay, so right, here we go. We've got a new terminal, and what we can do is we can SSH as root into 172.22.0.2. That is the IP address that the Docker container has given us for working with. And it's saying we've never connected. Are we sure we want to continue? Say yes. Type in the password of password. And we can see we're now connected to a completely separate machine. Remember, this is the host name down here. We can cat the etc passwd file to see that there's no Kali user account, there's no Dan user account, there's nothing here. This is a completely separate machine. So what I want to do is be able to copy and paste files from my Kali machine onto this computer here. So let's exit out of this SSH instance. What I'm going to do is I am going to create a file on my Kali host that I'm going to copy onto that remote Docker container. So I'm going to turn around and say echo local file on Kali host. And that's going to be in a file called test. So you can see I've got a file called test. I'm just going to remove that remote on Kali 1 so that later we can see that it's been copied properly. So I've got that test file here. This is on my local Kali machine. Now, if I want to be able to copy that across, what I can do is I can use a tool called SCP. This is essentially secure copy. It uses the SSH protocol, that secure shell protocol that we've got the ability to use. And we can turn around and say, I want to copy this file onto a remote computer. So 172.22. And I've got to put it somewhere on that computer. And a good shout is to use the temp directory. Everybody has write access to the temp directory. So what I can do is say, copy my local test file onto that temp directory. We get this little progress bar come up saying, it's copied 100%. It's copied very quickly because it's only a small file. And now if I SSH onto that remote host again, 22.0.2, if I change directory to the temp directory, I have that file test. If I open that up, local file on Kali host. So that's how I can take a file from my machine and copy it onto a remote computer. This can be really helpful when it comes to copying tools from your machine onto a remote computer, copying lists of target IP addresses potentially, can be really helpful. But what if we've got a file on a remote computer and we want to bring it back onto our machine? What if we've done some kind of test or scan and we've got evidence on that remote computer and we want to bring it back onto our Kali machine? Well, let's look at how we can pull that data back. What I'm going to do is create a file. So I'm going to just echo, this is a remote file created in the Docker container. I'm going to put that in a remote file. So now we can see in the temp directory, I have a file called remote that has this text in it. Let me exit out of this SSH interface. Back onto my Kali machine now. We can see I'm back on my Kali machine. If I look at my temp directory, it does not have any of these files in them because it was a different computer. Okay, so we are currently in the home Kali directory, and what I want to do is grab that remote file from a remote computer. So I can use that scp command again, and this time, because it's a remote file, I'm going to just make sure my computer knows who it's logging onto. It's logging onto 172.22.0.2. It's logging in as root, and it's going to go to the temp directory and get that remote file. Now, because I'm copying this file, I can call it whatever I want. So I can call it copied remote or anything like that if I want. I could call it remote if I wanted to, but this is going to reach out and authenticate to that Docker container through SSH, and then it's going to pull that remote file. And now, if I list the files, I can see that I have copied remote. And this is a file that was created on a remote computer that we've copied across using SSH. It's a really helpful skill to have because, as I said, most Linux machines will have SSH open. Most of the time you will be navigating through computers via a terminal. And so it's really helpful to be able to not have to take snapshots if you want to be able to have evidence of a file, not have to try and copy and paste and worry about clipboards, but to just be able to extract the data that you want from files and bring it back to your testing machine. And so that's our introduction to Linux. I hope it's been really helpful. Go and have a look at the North Korean Learning Linux GitHub repository. I'm just going to bring that back up again, as that can be really helpful to learn some of these commands and practice some of these techniques that we've talked about. Okay, so go and get that. It is on github.com North Korean Security, and it's called Learning Linux. There is a exercise workbook to go through. It is using this tool, so it will create the exercises for you. It will create files and folders for you to work with, and then at the end you can delete them all off of your machine, knowing that you haven't caused any persistent potential errors. And it's just going to be helpful to make sure that you can work through the kind of techniques that you're going to need to use. The worksheet itself also has exercises on things like setting IP addresses. It's got commands that's not in the tool itself because that's, we don't want to screw up people's Linux machines, but it's got help in making sure you can understand the difference between dynamic and static IP addresses, all that kind of stuff. So go and grab that if you think that's useful to you. Go and practice, and I look forward to sharing more videos with you in future.